So here we have the Singer 114K103, which is the same as a 114W103, except for where it was made. The cover plate here is off, and I have a servo motor running over here, and instead of a foot controller, I have wired in the foot controller circuitry to this switch here. I don't know that you can see it or not, but I'll show it to you in a little bit. And I can control very slow speed on this thing. Now I've already got it threaded and it's sewing, so I'm going to show you how that works. Now it's going very slow, and I'm controlling how it's going with my hand. I'll speed it up a little bit. I have it going relatively slow. It's not, the maximum speed is not going to be very big, very fast. You can see it's doing a chain stitch. I don't know if you can see that or not, but I'll zoom in on it in a little bit. Now obviously I have no skill in doing this, so I am just going around and around and around and showing you what you can do. But the unique thing is this chain stitch machine shows you the chain stitch while you sew it, versus some of the hand ones that Cheryl uses now sew the chain stitch pattern on the other side of the fabric, and you cannot see it until after you're done. Pretty cool. And as soon as I let go of the handle, it's going to stop. Ready? Just like that, it's disengaged. You can hopefully see the chain stitch as they're being made. I'm going to try to control the speed. That's pretty dang slow. Probably about as slow as this machine can handle. Can you see the chain stitch thread being formed? The needle bar, which is, this goes up, comes out of the top of the machine, has the needle screwed into it, and the needle itself is threaded on one end, which is very unique among needles. I've never seen that in any other sewing machine except for one of these chain stitch type of machines. And there's a hook on the bottom of it. Instead of an eye, it's like a, I guess, like a crochet hook. And it reaches down underneath, all the thread is underneath, and it hooks the thread, pulls it up, moves the fabric, drops it back down, and hooks the thread, draws it up, moves it back down, over and over again. So this is a one thread making a chain stitch, which, if you know chain stitches, they can unravel very easily if you're not careful how you close them off and end them. There's another type of stitch this machine does called a Moss stitch, M-O-S-S. And in order to do that, you have to take the needle bar and rotate it 180 degrees, turn the hook facing the other way, and what it does is it brings the thread up and makes a loop on the top, but doesn't reattach it. So basically you have a bunch of little loops, almost like a terry cloth fabric or terry cloth finish. It's very soft and fluffy, and you can see the hook on the end of it. This is a rather large diameter needle. They come in all sizes, standard sewing needle sizes like 70, 80, 90, 100, all the way up to like 160, maybe even bigger. I don't know exactly, but way bigger than I would ever use. So there you go. You can see the needle. I'm going to show you the threaded side. It's very interesting. Okay, so you can see the needle bar is pretty good size. See if I can lay it down there for you to see it. The needle screws into one end, and you actually do have to use a pair of pliers to make it tight. You basically just put it in there. You can look all this up on the internet if you're interested. You turn it in, turn it, turn it, turn it, turn it, until it gets snug. And then The whole thing slips down inside this machine, and I will show you that. So this is the needle bar, and there's a little nut here that you can undo and move this needle bar up and down. At the very bottom of the needle bar is a nipple, and the nipple screws into the bottom of the shaft, not the needle bar, but the needle slides through the nipple. Yeah, you don't want to, you pull on this and it's going to unravel, so you have to thread this through. There's a process involved in keeping your chain stitch from unraveling. If I pull on this, it just pulls apart, just like you would see on a dog food bag or a cat food bag. So I want to show you this modification I did to this wheel, and I want to thank Mike Anderson from Wolfgang Antiques, or Collectibles, I think it is. He had posted a picture on Ismax, which is a vintage sewing machine repository of useful information. You'll find lots and lots of really good stuff there. And he had a picture of one of these sewing machines. So I looked at it, and it had a wooden wheel mounted on the end, just like this does. Absolutely blew me away, because the biggest problem I was having was making this thing go slow enough. The wheel, the standard wheel on this machine, there's two diameter pulleys. This is the, you can't even see it. The largest one is underneath this wooden thing, and then there's a smaller one, but the largest one is only 3 or 4 inches in diameter. This is a 7.5 inch or so diameter, which is great because I'm using a very small diameter on the motor and a large diameter on this, and it gives me about as slow as I can get without going, well, I can't really do a whole lot more. I can make this wheel a little bit bigger, but anyway, the idea here is that this is slows the machine down. And what I did was I took, I'll show you the side plate. This machine had a different kind of setup on the side here that was hooked up, meant to be used with foot pedals for treadling, you know, on a table, where you would sit in front of the machine and push the foot pedal to control the speed of the machine, as this foot pedal would go to this, which had a sensor in it. So I took the sensor assembly apart, and all it was, besides all the mechanical stuff on the outside, was an optical sensor with a thing that went through the eye of the sensor, and as it went through, the density of the thing that went through the sensor slowed or sped up the motor. So I reverse engineered that and found out that the connector cable, which is a 3-wire cable used between the circuit board in here and the sensor assembly on the outside, was a standard connector cable used like for cooling fans and PCs. Well, I know you can get cooling fan extension cables for PCs, and they're real cheap. So I bought a bunch of them, and they connect up together, and so I basically extended this cable all the way into this box that I made. And the box has the sensor assembly from the piece that was on the side inside of it. And I made my own wheel so that I had a 180-degree turn. I could have gone 360, but I went with 180 and 180-degree sensitivity. So it goes from 0 or off, and you can see this is a cycling of, oh, yeah, I don't know if you can see that or not, but anyway, it's not doing anything, and it's off. And as I turn this slowly, I get more and more speeds. Now I'll tell you that you can't see what's on that display output, but it says 1, and 1 is the slowest output that motor goes. And then as I go a little bit further, I get a 2, and I can get a 3 and a 4, and all the way to the max. And the max is right now set to be 12. So this thing can go a lot faster than 12, and 12 is some sort of RPM multiplication number. If you go past that, it goes back to 0. But basically, it shut off the power. Power's off, power's off, power's off, back on. This is the technique we're going to try. We're going to see how this works. I am going to put a on-off switch, foot pedal activated, where you have to keep the foot pedal pressed to keep power going to the motor, so that if somebody's long hair gets wrapped up in this unprotected belt, they can let off the foot pedal and it'll stop. And then there's also a plate that goes across here and covers this, but I thought it was interesting to be able to see the gears. And I actually made this wheel after seeing that photo from Mike Anderson on ISMAX. I had a piece of 2x8 or 2x10 or whatever it was, standard pine, and I cut it out and made myself a wheel, grooved it. I did most of this, I did the outside diameter of the wheel on a drill press, on a floor model drill press, and the rest of it I did on my metal lathe. I cut a groove in it, and this mounting gizmo here, I had spent some time deciding on how to do that, but it's basically not attached to this desk. It's just it's got a front piece like this, and it's got a back piece very similar. I don't think you can see it very well there, but basically it'll slide. And so if I want to tilt this machine all the way back, I can, and I'll show you that in a second. Let me shut the machine off now. Okay, now the machine is shut off, so I'm going to tilt the machine back a little bit. I have a couple locking mechanisms under the table here to keep this machine from going anywhere. Let's see, let me unlock them and I'll rotate this table back for you. As I turn this handle, the front of the machine is turning. Can you see that? And this is how you guide the needle and with the direction of the sewing. Basically, this changes the needle bar, the looper, and everything, and it continues to operate on the machine as long as you keep this handle pulled down. Well, I can't pull down on the handle, but there is a up and down portion of this handle, and one of these engages and disengages the drive. So when you let go of the handle, the machine shuts off. So there you have it. And that is a summary of this embroidery machine.